So this time we're going to be using the derivative to find the equation of a tangent to a function. So we've seen this function before. It's my pilot. He's flying up, he's flying down over the course of 30 seconds. He goes up to about 11,000 meters and he comes down to about 2,000 meters. Now, at the 29-second mark, our stunt pilot has a secret. He's got rockets, and so he's swooped down, and the plane is flying along this trajectory, and then he launches the rockets. Now, obviously, the rockets are going to go in a straight line. So what we're going to end up with is a tangent to our function at that line. Let's see what that looks like on GeoGebra. All right, so here's my function. At the 29-second mark, he lets fly with a rocket. Now the rocket is going to leave the airplane and take off. And you can see that the tangent, this is called a tangent. The tangent is just touching the equation. So it's got the same rate of change as that instantaneous moment at 29 seconds. So if we know the rate of change at 29 seconds of this function, we'll know the gradient of this function. And you can all do that. So find the equation of the tangent at the 29-second mark. First thing we need to do is know the instantaneous rate of change at the 29-second mark. Our derivative function will help us out. Now we need to know at the 29-second mark. So that x is time. So sub 29 for x into f dash x. Now the answer here is 992. It's a gradient, so it's meters per second. So our rocket's going to take off at a slope of 992 meters per second. So it says find the equation of the tangent. Find the equation of the tangent at the 29-second mark. So we know that this is a straight line, and we know that straight lines always have the function y equals, or the equation y equals mx plus c. We know that m is the gradient, so we know that this particular red line is y equals 992x plus c. Now, we need to know the c value, otherwise we don't know the equation of the line. Now, what else do we know about this line? Well, we know that it passes through this point here, 29 something. So if I sub 29 into my original equation, I'll know what that point is, 29 something. All right. The answer here is 3856. So the rocket passes through point 293856, and it has a gradient of 992. So now that I know a single point on my line, I can sub 293856 into this equation, y equals mx plus c. So negative 24912. So there's my c value. We were asked to find the equation of the tangent. Very last step here. The answer is y equals gradient 992x minus 24912. Alright, that's how you find the equation of the tangent to a function.